We did see some glimpse of how to use a log table, but now we are going to dive into all the details. We'll see different problems and cases in which calculations are done using log table. Convert some variables or numbers into new values. And these numbers can be converted back to their original value using the anti-log table, and yes, we will learn that too. Let's find the log of 1.23. The first step we have to take is to round off the number so it's log compatible, and to do that, we adjust the place of decimal. Place it always after the first digit. In this case, the decimal shift is not needed as it's already where it's supposed to be. And we multiply the number with 10 to power function, where we put the power as the number of shifts we made to get the decimal after the first digit. And since we didn't shift the decimal in this case, we multiply 10 to power 0. Next, we apply log of multiplication. We then get log of 1.23 plus log of 10 to power 0. Next we apply log of power to remove the power of 10, and after that we use the property log of number with the same base, which makes log of 10 to base 10 as 1. 1 times 0 becomes 0. And, from now on, this trend will always proceed in log table, so we can just casually remove the power of 10 without any hesitation or mentioning the properties also. And, we get log of 1.23 plus 0. Here the log of 1.23 is known as the Mantissa, and the 0 is characteristic. Since characteristic is found already, we now only need to find Mantissa. And to find Mantissa, we use a log table which looks like this. Let's zoom in for a closer look. The number we need to look is 1.23. And for a moment I want you to ignore the decimal over there. First we will take the first two digits of the number, which is 12 in this case, and find its place on the leftmost column, and hold that position. And then we find the third digit's place on the topmost row of the table, which is 3. And we observe, where do they both meet, and they meet at 899, we note down this value. And since there is no fourth digit present, we don't need to go through the mean difference table. The mean difference table is right next to our log table. The number 0899 we found in log table needs a little tweaking. We put a decimal before it, and get 0.0899. Now all that is left to do, is to add the characteristic, and Mantissa, which gives our final answer to log of 1.23, as 0.0899. Next number we find log of is 123. Kinda similar to the previous one, but still important. So first we round off the number, and to do that, we put a decimal after the first digit, and get 1.23, but, to shift the decimal, we need to multiply the number with 10 to power 2, so we need to find log of 1.23 times 10 to power 2. And we can now directly jump to our characteristic, and Mantissa, because we know, this is how it's going to end every time. The characteristic is 2, and the Mantissa we need to find is log of 1.23, same as previous problem. The log table yields out the same answer as 0.0899, and we still don't get to use the mean difference table. And finally, we now add the characteristic and Mantissa, and get the answer of log of 123 as 2.0899. The next number for us to turn into log is 1, 2, 3, and 4. Let's see how this one works out. For rounding off the number, we shift the decimal places 3 times to the left side, and multiply 10 to power 3. The rest follows as expected and we get Mantissa as log of 1.234 and characteristic as 3. Now we have a 4-digit number to find in log table. As usual, we mark the first 2 digit on left side column, and the third digit on the top row, and get 0899. But since we have a 4th digit also, we get to use the mean difference table. We just stick to the same row as our log table, and mark the digit on topmost row, and see where these rows and columns intersect. Let's zoom in for a better look. And we get 14. What should we do with the mean difference? Simple, we just add it to the value we found in log table. So 0899 plus 14 gives us 0913. And don't forget to add the decimal after the first digit, so we get Mantissa as 0.0913. Finally, we add the Mantissa and characteristic to get log of 1234 as 3.0913. The next number we have to convert using log is 1, 2, 3, 4, 5, 6, and 7. Here the rounding off might go a bit differently. We put the decimal after the first digit, as expected, and to do that, we need to shift the decimal 6 places to the left, and we multiply 10 to power 6. This is textbook, and shouldn't be a problem, but we also round off every digit after the fourth one to 0, so 5, 6, and 7 are now 0. We do this because we really don't have use for them in log table. We find first 3 digits on the log table, and the fourth digit on the mean difference table, and after that, all the digits go meaningless and lose their value to 0. After this rounding off, the next step goes as usual, and we get Mantissa as log of 1.234, and the characteristic as 6. We have calculated the log of 1.234 before, which came as 0.0913. Finally, we can just add the characteristic and Mantissa to get our final answer, which is 6.0913. The next number we are going to convert using log is 0.001234. Again, rounding off is going to be a little different here. We need to put decimal after the first digit, but also that digit must be a non-zero number, so here a non-zero number is after the first 3 digits, so we shift decimal 3 places to the right side this time, and to compensate we multiply it with 10 to power minus 3. After this, we follow the same mechanical process which leads us to log of 1.234 as Mantissa and minus 3 as characteristic. Here we know the value of log 1.234, which is 0.0913. In this case, to find our final answer, we now need to subtract Mantissa from characteristic and get log of 0.001234 as minus 2.9087. But instead of writing minus 2.9087, we will write it as 2.9087 and add a bar to the top, just to signify that this answer is a result of a very small number, not a negative number. Don't worry, we'll see why we did this in a few moments. Let's see different examples all together in a table to see log operation clearly. Let's write down the numbers we are going to convert to log. I know we didn't convert 12.34, but it's just there for simplicity. And now we round them all up as required. After that, we apply the log formulae to separate characteristic and Mantissa. We then find the Mantissa on log table and add the characteristic to get our converted value. So this is what the operation with log looks like, but wait. What if all the numbers we found were negative? Does that affect our answer in any way? Let's find out. Log of negative numbers is pretty easy. We just take the negative sign outside the log and solve just as we'd solve a positive number. For example, log of minus 5 is minus log of 5, and log of minus 1.23 is minus log of 1.23, whose value we found out as 0.0899, which in this case will be minus 0.0899. So now we make the answers negative. Notice the final answer, the log of 0.001234. We added the bar over 2.9087 to indicate that this is a negative number. And this is why we add the bar, because we want to avoid confusion, whether the number is negative because it is a negative number, or is it a number smaller than 1. Hence, we always represent the answer to log of a number smaller than 1 with a bar. So let's just set up an algorithm of what we've just learned. The very first step is, we round off the number in a specific 4-digit value, with decimal after the first digit, ignore digits after the fourth one and write down 10 to power multiple to compensate for adjustment we made for the decimal shift, apply log properties and place out the characteristic, then find out the value of Mantissa on log table, use mean difference table when needed, and add both characteristic and Mantissa to get the final log value from the log table. Now that we have converted a given number or value into another, the question that comes to mind is, can we get back our original number? And, to get back our original number, after converting it using log, we use any log table, and yes, the any log table also has base 10. Just like log table, it is denoted as AL, and is written as any log of 0.233. We will learn more about any log in next video. Till then, stay tuned.